Hello again. We are on intersecting secants and tangents. So the tangents are honestly my favorite because I think it looks like a party hat. See the little person smiling with its party hat on? Or it looks like an ice cream cone. So either way, I'm happy. But whenever it looks like this and you have two tangents touching, anytime two tangents touch, they are equal. So it's pretty simple. You have this equal to this. So 2x plus 7 equals x plus 18. Go ahead and solve, and we'll end up subtracting x, subtracting 7, and getting x equals 11, and boom, we're done. Over here on the right, again, because the two tangents are touching, it's going to be that x plus 6 equals 2x minus 5. Subtract x, add 5, x equals 11 again. Total coincidence. Okay. Then you have two more scenarios that both follow the same rule. So because the secants or the tangents are touching on the outside of the circle, I use the following rule. Outside times the whole equals outside times the whole. And of course, I'll show you what that means, okay? Just a quick reminder from the last video that I just happen to have right here. When they crossed on the inside, the rule we used was part times part. Because they're crossing on the outside, right there, we're using outside times the whole. So the outside piece of the secant is the part that's on the outside of the circle. Sorry that it just went a little bit out of focus on you. The whole thing would then be from N all the way to Q. So that's the whole. So 8 plus 4 is 12. Down here, we have 6 as our outside piece. And then 6 plus X, not 6X, be careful of that mistake, as the whole piece. So now we just follow the rule that I said. So it's going to be outside times the whole, so 12. And then here I just need to remember that when I do outside times the whole, because the whole is 6 plus x, that goes into parentheses so that I can distribute appropriately. So 4 times 12 is 48. And then we get 36 plus 6x with distribution. 48 minus 36 is 12. And x equals 2. Always double check what it's asking for. Find the length of each secant segment. This entire thing is the secant, so that would be 8 because 6 plus 2 is 8. On the next one, if I'm doing outside times the whole, I have 8 as my outside piece, so that's the outside. The whole would be 8 plus z because that's the whole thing. Down here, I have 9 as the outside piece, so equals 9 times. You can write 9 plus 9 if you want, but I'm just going to write it as 18. Over here, I distribute 64 plus 8z. Over here, 9 times 18 is a number that I'm about to tell you because I don't know what it is off the top of my head. 162. Subtract 64 from both sides. I just didn't do that, but I'm about to. I get 98. So 8z equals 98, and then when I divide by 8 on both sides, I get a decimal, which is okay. If I wanted to double check my work, I could. So 64 plus 8z, 162 minus 64. Yeah, I'm all good. So 49 over 4, and then you have to remember it asks for the entire secant. So I'm gonna add 8 to that, and I get a number that I'm gonna tell you, 81/4. Okay, on the last two, it looks a little bit different. The only thing you have to realize is, okay, outside is 4, whole thing is 16. Here, the outside is both itself and the whole thing because there's nothing else there. So this is what that'll look like. 4 times, sorry, the zooming because I keep writing. 4 times 16 equals, x is both the outside and the whole. So that will just repeat. So 4 times 16 is 64. X times x is x squared. Square root both sides, 8 equals x, and that's what they were asking for this time, the variable. On the right side, outside times the whole, so 6 times 6 plus y equals 9 times 9 because it is both outside and the whole. 36 plus 6y equals 81. 81 minus 36 is 45. So I get 6y equals 45. 45 divided by 6 is 15 halves. So I'm done. Okay, so basically tangents are equal when they touch, and for when they touch on the outside, outside times the whole equals outside times the whole. That's it. Have a great day.